Here we're going to look at derivatives of trig functions. For example, it turns out the derivative of the sine function is the cosine function. The derivative of the cosine function is the negative sine function, or negative 1 times the sine function. And the derivative of the tangent is the secant squared. We won't derive any of these here. These are just facts that you'll memorize in order to solve other problems. Let's set those aside for now. Here's our first example. When you're taking the derivatives of trigonometric functions, obviously you use the same rules you would for any other derivatives. Derivatives haven't changed just because trig functions are in them. So here we'll apply a rule that the derivative of a constant times a function is the constant times the derivative of that function. This has nothing to do with trigonometry. This is something you've been using your entire time as a calculus student. Now, to take the derivative of the sine of 2x to the fifth, we have to use the fact that the derivative of the sine function is the cosine function. But again, just because trigonometric functions are involved doesn't mean all the other derivative rules go out the window. And so we'll use the chain rule here, just like we would for any other nested function. Yes, the derivative of the sine is the cosine, but according to the chain rule, we then multiply by the derivative of the argument of the first function. If it's been a long time since you've studied the chain rule, you may want to go back and take a look at that, but that's what we're using here. And finally, you can compute the derivative of a polynomial as usual, and we can rearrange the order of multiplication and simplify a bit, and that is the derivative of this function. Here we're going to take a derivative of tangent cubed x. In case it's been a long while since you studied trigonometry, when we write an exponent above the name of a trigonometric function, what we really mean is that the function is being raised to that power. For some strange reason, tradition has dictated that we write the exponent above the name of the function, but it really means we're cubing the entire function, or whatever the exponent may be. So now we're going to take the derivative of something cubed. Well, as we've always done in calculus, the derivative of something cubed is 3 times that something squared. And according to the chain rule, we then multiply by the derivative of the inside function, which in this case is tangent. Now here comes the trigonometry. The derivative of tangent is secant squared. That's just one of the facts we're going to be memorizing. So I can replace the derivative of tangent with secant squared, and I'm essentially done with this problem. I'll put the 2 exponent back where it traditionally belongs, and that is the derivative of tangent cubed. Here we're going to take the derivative of x times cosine x. Once again, just because trigonometric functions are involved does not mean all the other derivative rules are gone. Whenever you're taking the derivative of a product, you use the product rule. You may want to hit pause here and realize I'm using the product rule from many, many lessons ago. And now, since the derivative of cosine is the negative sine function, or negative 1 times the sine function, again, that's just something we're memorizing. I can replace that derivative with negative sine x. Notice also on the right-hand side of the expression, the derivative of x is 1, of course. Cleaning this up a little bit, I'm now done with this derivative. Partial derivatives can also be used with trigonometric functions, of course. That shouldn't come as any surprise. Here we're going to take the partial derivative with respect to x. In case you forgot, that means we are considering y as a constant. But nonetheless, we do have a product of functions of x here, and so I'll once again use the product rule. This may be a good time to hit pause and analyze the product rule. And now it's just a matter of working out the derivative, the 2 derivatives that come from the product rule. Since in general the derivative of the cosine is negative 1 times the sine function, I can simplify the partial derivative of the cosine the way I did there, again using the chain rule as the second product there to multiply by the derivative of the inside. And finally, considering y a constant, those 2 partial derivatives can be easily worked out. And after simplifying, we have our final answer.